Hello students, so let's learn about combinations today. Okay, so in combination, order is not important. Okay, now if there are three things, say x, y, z, and we have to choose two things at a time. Okay, then if I'm choosing x and y, then y and z, and then z and x. Okay. So this is like a combination, that is selection is called a combination of three different objects taken two at a time. Okay. So next example is 12 persons are there in a room and each shakes hand with all the others. So 2 persons are shaking hands with each other, right? And 12 different people are there. So 12 different things taken at two at a time. That will be the combination. Okay. Then another example is if a circle is there and there are 7 different points on that. Okay, and we have to draw a chord. Okay, so the possible combination is 7 different things taken two at a time. Okay, so we can write this as an example. If 5 different objects are there and we are taking 3 at a time. Okay, so the combination is given by 5 C3 and we have to multiply by 3 factorial. Okay, because arrangements are done in 3 factorial ways. First time this arrangement, then second time this arrangement, third time this arrangement, like this. Okay, so this is permutation, that is 5p3. Okay, so from this we can write the formula. Okay, that is NPR is given by NCR into R factorial. Okay, and our formula for combination is given by NCR equal to n factorial upon n minus R factorial into R factorial. Okay, this is the formula for combination. Okay, if you put the value of n and R, so NCN is 1. Okay, NC0 is also 1. Okay, then we have here NC n minus R. This is given by n factorial upon n minus R factorial into R factorial. So this is R factorial and this is n minus R factorial. So this is n factorial upon n minus R factorial into n minus n plus R. So this is R factorial. Okay, which is same as NCR. Okay, then there is one more point, that is if it is given NCA is equal to NCB, so we can say that A is equal to B, correct? Or N is equal to A plus B. Okay. There is a theorem NCR plus NCR minus 1 is equal to N plus 1 CR. Okay, this we have to prove. So starting from the LHS, NCR is n factorial upon n minus r factorial into r factorial, okay, plus n factorial upon r minus 1 factorial into n minus r plus 1 factorial. So now we have to simplify. So whatever we can cancel out, we have to see it, okay. So r factorial, we can write it as r into r minus 1 factorial, because here r minus 1 factorial is there. So we can take this out, correct? Also we can take out n factorial. This also we can write it as n minus r plus 1 into n minus r plus 1 minus 1 factorial. Okay, so we can take common n factorial upon r minus 1 factorial into 1 upon n minus r factorial into r plus 1 upon n minus r plus 1 n minus r factorial also you can take common. So here it is 1 upon r and this is 1 upon n minus r plus 1. Okay, this you can cross multiply and you will get this. So r and minus r gets cancelled. N plus 1 upon r into n minus r plus 1. So you can take this with this. Okay. So r minus 1 into r n into n factorial will be n plus 1 factorial. Then r minus 1 factorial into r, this will be r factorial. Then n minus r into n minus r plus 1, this is n plus 1 minus r factorial. Okay, so you will get the RHS. Let's solve second one. This is a question. If NC9 is equal to NC8, okay, you have to find NC17. Okay, this we have seen. A is equal to B, like that. Okay, but here A is not equal to B. Okay, so we have to solve this. So using the formula n factorial n minus 9 factorial into 9 factorial n factorial n minus 8 factorial into 8 factorial. Okay, 9 you can write it as 9 into 8 factorial. So 8 factorial gets cancelled. This also gets cancelled. N minus 9 minus, no, this we can write it as n minus 8 minus 1. So n minus 8. So this also gets cancelled. So you will get n minus 8 equal to 1. So n is equal to 9. Oh, here 9 is there, sorry. N minus 8 equal to 9 you will get. So n is equal to 9 plus 8, which is 17. So we have to find this NC17. So N is 17. 17C17 is 1. NCN is 1. Okay. Next question, it is a word problem. A committee of 3 persons is to be constituted from a group of 2 men and 3 women. In how many ways can this be done? How many of these committees will consist of 1 man and 2 women? Now here we have to constitute a committee of 3 persons. Okay, so our N is 3 and it is to be constituted from a group of 2 men and 2 women. So keep in mind that whenever and is there, you have to multiply. Okay, and whenever or is there, you have to add. Okay, so this will be what you are choosing. Oh sorry, this is not, N is not 3. Total people you have are 2 men and 3 women. So total is 5, out of which you are choosing 3 people, right? So your N is 5 and R is 3. Okay, so this will be 5C3. Okay, now they have given in how many ways can this be done. So 5C3 ways. So you can solve this 5 factorial upon 5 minus 3 factorial into 2 into 3 factorial. So 5 factorial upon 2 factorial into 3 factorial. 5 factorial is 5 into 4 into 3 factorial. Okay, so this is 2 2s are 5 2s are 10. 10 is the answer. Okay. Then the second thing is how many of these committees will consist of 1 man and 2 women. So there are 2 men, out of which we have to select 1 man. And there are 3 women, out of which we have to select 2 women. And is given. So N is 2. So 2C1. Out of 2 we are choosing 1. Okay. And into 3C2. Okay.